Happy Thursday, everybody. It's Mr. Marquardt rocking with you guys. We are doing wrap-up weekend number 3, just to kind of tie this week all together from 411 through 413, talk about all the important stuff that we talked about in class this week. So hopefully if we missed anything, this is a great chance to get all that stuff wrapped up, get any questions answered, and hopefully tie all these concepts together. So again, we are starting with trigonometry. So if we define trigonometry like we have in our comic here today, it's going to lead to a weapon of math destruction, which is, I think, a perfect joke to end this week because we are jumping in with trig and we're going to start doing more with tangent as we go through the next couple of weeks, and it's going to be a lot of fun. So a couple of reminders. So today, Thursday, December 3rd, we have a quiz this weekend. So make sure you take that at some point before Monday. So we'll post that probably this afternoon around 3:30, somewhere in that neighborhood. But otherwise, what's on it is just kind of a general review of everything we've done this year so far. So nothing on it should be anything new from what we've done up to this week. So nothing from chapter 4 is on it, but anything that we've talked about so far this year is going to be fair game. So just be ready for that and make sure you take that at some point this weekend. Plan for next week. So next week is Group B. So Group B people will be in person. So Group A, you'll have a virtual lesson on Monday. So use It's Learning. Lesson 414 is super important. So please make sure you guys are doing that asynchronous lesson at home for Group A and our full virtual students. Group B, you'll be in person, so we're going to do it anyways. So we'll have a homework assignment that day. Tuesday and Wednesday will both be live class. We're going to finish section 4.1 on Tuesday. We're going to start chapter 5 on Friday or on Wednesday. And then Thursday next week, we'll have another wrap-up weekend talking about tangent, sine, and cosine, all that trig stuff that we're going to jump into pretty heavy next week. So again, Monday is super important. You absolutely cannot miss that lesson. Otherwise, you're really just going to be hurting yourself as we go forward through chapter 4 and chapter 5. So one really important piece of information that we want to talk about as we get near to the end of quarter 2 and semester 1 is our test retake policy. So up to this point, we've taken 3 tests, with 1 to come after Christmas break here for chapter 4 and 5, and we are allowing everybody to take 1 test or retake 1 test for up to full credit. So we want to look at the most points available, maybe not percentage-wise, because if you have, let's say, a test that's worth 30 points versus 25 and you got a lower score, like say like if you got 20 out of 25 versus 20 out of 30, you can get more points back, which is going to help boost that grade overall because that test category is all lumped together as one in the grade book. So the more points you can add back, the more or the higher your percent is potentially going to rise when you retake your test. So you can retake any 1 test up or out of the 4 that we will take by the end of the semester. You can retake them up to the last week of the semester. So the deadline for doing this is January 11th. So if you are interested in retaking a test, you have to do it before January 11th. So after the last test, you will not have any time to discuss your retake. So you must think proactively here. So to retake a test, first, you have to email your grading teacher, whether it's me, Mr. Moe, Mrs. Curtin, or Mrs. Millard, and then do corrections on your first version. So you have to go over the test. We'll talk about what you did wrong, how we can fix it, and make sure that doesn't happen again. And then you can take the retake. So only then can you take the retake, but you have to meet with your grading teacher first. We're happy to meet with you guys outside of school. You have to reach out to us and plan according to when you have some free time. And we have a busy schedule too. I know that there's students back in the building, so you have to be a little flexible and work with us at that as well. So again, kind of think ahead now if you want to start retaking a test, because if everybody comes to us at the last week of the semester, we're not going to have time to squeeze everybody in. So please be proactive and think about which tests you might want to retake so you can get in and do corrections sooner than later. So this is also an important note. The score that you get will completely replace your old score for better or for worse. So if you, let's say, have a 75% on, let's say, chapter 1's test and you want to retake it, hoping you can get a 100. If you, for some reason, get a 60, that 60 replaces the 75, which is unfortunate. But that's why we want to do corrections so that doesn't happen. So last year when we did our test retakes, I think we only had 1 student out of maybe 50 that did retakes last year that didn't improve on their score, and it was a marginal decline in their score. So if you come meet with us, the chances of you doing worse in your test are very slim, but make sure that you are proactive and come out and do those corrections with us. Again, email your grading teacher to communicate about a retake or with any questions. So now let's jump into what we did this week. So we talked about slope angles and slope ratios quite a bit. Again, slope, when we think back to algebra, is our change in y over the change in x, describing how a line grows, or like that steepness of a line. So we learned that if we, let's say, have a slope triangle here with 11 degrees as our slope angle, we know that that change in y would be 1. Our change in x is 5. So if we write that as our fraction for slope, it is a fifth. So when we talked about that in context of like that slope ratio, again, that was a fifth. If we looked at the other angle of that triangle, that complementary angle, because again, 11 and 79 here add up to 90. Any two angles that add up to 90 degrees are always complementary. Again, give somebody a compliment, give them a high five, compliment, high five, 90, right angle, complementary angles add up to 90 degrees. So again, 79 degree slope triangle implies that we have our rise of 5 and our run of 1. Again, because if we take this triangle, we rotate it and we flip it, so it looks like this one. Rotations and flips are both rigid transformations. So nothing about that triangle changes other than its orientation. So those sides are going to stay exactly the same. So if we look at the line that is associated with that 79 degree slope angle, again, that rise is 1, or the rise is 5, excuse me. The run is 1, so then that slope is 5 over 1. So if we look again at 1/5, 5 over 1, when we have a fraction and we flip it, so those numbers are flipped around like that, we call that the reciprocal slope. So again, opposite angles in that slope triangle have a reciprocal slope. And hopefully that word reciprocal sounds familiar because we talked about that back, I think, in chapter 1 or 2 when we're talking about perpendicular lines. So that was hopefully a familiar vocabulary for us. So this is also one thing we did this week. We filled out our trig table toolkit. Hopefully we have this filled out from class, but if you need to fill out anything on here, I will move my face so you can see all the numbers, but you can pause the video. That's the beauty of a video. Fill in those numbers on your trig table toolkit so we can use this on our homework going forward. Here's the second page. Again, this is all the numbers, and again, this is the beautiful thing about a video. Pause it so that way you can copy all this stuff down if you missed it in class this week. All right, and then last thing, we're going to do a couple review problems just to kind of tie the knot and make sure we understand all the concepts. Again, like we talked about just a couple minutes ago, we have, in this top left one, we have our slope angle given to us, and we are missing a value on that triangle. So we can use that slope angle and the corresponding slope ratio to find that missing value. So if our slope angle here is 11 degrees, again, we know that 11 degrees, that slope ratio is a fifth. So if we draw a slope triangle for that 11 degrees, like the generic one, if we go back a couple pages, I'm not going to, just for the sake of everybody watching this, we don't want the flashing slides to give anybody a headache or anything like that. So let's see here, that 11 degrees was right here. We know that that side was 1, this side was 5. We have a right angle. So those are similar triangles. So again, like we've done in class all week, now that we have similar triangles, we can set up a proportion and then cross multiply to find what this value of W is going to be. So we have our rise and our run over here of a fifth. So let's say we have a fifth on our big triangle with our missing value. This W here is our change in Y, that up and down value. So this is W up on top. And then on the bottom, we have 47, which is our run for looking at that slope triangle. From there, we can cross multiply. So we'd have 1 times 47, 5 times W. So if we cross multiply and follow all of our steps through, I'm going to skip the work for the sake of time, but our W would be equal to 9.4 here if we do our math right there. All right, let's go to the one on the right over here next. So we have our 45 degree slope angle, which is right here. We can just think about this maybe having a negative slope instead. Otherwise, you could flip that triangle over so it looks more familiar like this one. But if we think back to our trig table toolkit, our 45 degree slope angle always has a slope ratio of 1 to 1. So if we know that this side is 12.4, our slope ratio is 1 to 1, we know that this x has to be exactly the same as 12.25 right here. So this would have to be 12.25 because with a 45-degree slope angle, those sides of that triangle are always the same. So then if we want to find what this theta value is up at the very top there, again, hopefully we all remember that the angles inside of a triangle all add up to 180. So if we take this 90-degree right angle, 45 degrees, if we add those together, we have 135. We take 180, we subtract that 135. So what's left over is our angle up at the top of that triangle. So that would be 45 degrees again. And then we are good to go for this one. So this angle is also 45 degrees. All right, and then lastly, if we're struggling to see where our slope angle is, if we have something that's not oriented very nicely, we can always redraw this triangle. So if we redraw this triangle so it looks like a slope triangle that we're used to seeing, it could look something like this. And again, apologies for my drawings here, but we would have our angle for 70, which is our slope angle that's given to us right here. We would have our theta up at the top. Our change in y would be that 3.2. We would have this m value down here. Nothing changed, we just rotated that triangle so it looks a little more familiar for us. From there again, we got to find what our ratio for 70 degrees is. So if we go onto our trig table toolkit, we know that 70 degrees, our slope ratio is 13.75 over, or sorry, 13.73 over 5. And then if we set that equal to our rise and run over here, which in our missing value is 3.2 over m. Again, we can cross multiply, solve for that m value. When we do that, again, hopefully we all get the same answer, but it would be 1.16 for that m value. And then lastly, we got to find that theta value again, which is the same process we did up here. All the angles inside a triangle always add up to 180. Subtract 70, or add 70 and 90 together. Subtract that one from 180, so we should get this theta up at the top of our triangle here to be 20 degrees. And again, these should always be complementary angles. These should always add up to 90 degrees if we have a right angle in these triangles. So hopefully that helps tie some of the stuff together from this week. That's our weekend wrap up. I hope you all have a fantastic weekend. Look forward to seeing Group B in person next week. Otherwise, have a great weekend, everybody, and we'll see you all soon.